Hello, everyone. This is episode 138, the second part of Algorithmic Collusion. In this episode, we are going to cover an application of AI algorithms colluding each other in the context of stock trading. And here, basically, conceptually, what we do is that we have Q-learning traders, the informed agent B, A, and B, and then there's a market trader, a market adaptive market maker that basically sets, well, the price. So here, the trader A basically has an action of how much quantity to set, and then the order flow is also being watched by this and aggregated, plus the noise trader and information insensitive traders. And then eventually the price came out. So tracks the history of the price and value and keeps feeding and doing the Q learning. In the meantime, the reward is the profit that A collects and B collects, and it keeps going on. So a very similar idea to Calvano, except that um, this is using um, market trading context to using Pete Carl's famous econometric paper as a baseline. Okay, just to show you the paper itself is this. It's written by people at Wharton. Uh, Here, AI power trading, algorithmic illusion, and price efficiency. Um, and as I said, it is basically a similar idea. Q-learning algorithms are basically competing each other to get the best prices to sell, and they have to put an order, and which is aggregated by the market. But it's doing the Q-learning, as you can see here, um, like this, our typical Q-learning algorithm. And there are many things that you can do, but here is what's added is the price insensitive trader, which is a value trader. Let's say that if the average value, I mean, the actual value may fluctuate, but the average value relative to it, if the price is too low, then this insensitive trader will just buy. So it's a market correction mechanism. And if the value to the average long run value, the price is too high, then it will tend to sell. So this is unconditional from the informed trader's order. Um, and the market basically tries to um, minimize the inventory cost and the mispricing component here. Theoretically, you could prove that the market maker basically optimal price setting scheme is the price, the order, and the value, and some expectation of the observed order, expectation of the value, that what it is. Later, they show that in an implementation, you can have an adaptive market maker. Um, so in a simulation, they basically end up having the previous equation I showed you. You can show that the expectation of the value by observing past market is basically a regression running the value on past market prices, for example. Also, the information insensitive demand is basically by looking at the prices, and you can guess it by past history of it. So you plug them all in here and get it. So the market maker basically makes this equation in the implementation. All right. Let me show how the code looks like. It's a fairly simple code. Um, I put some annotations and all that. But basically, you have first the Google, mount your Google Drive to save it. I'm saving in some my YouTube, um, the Google Drive. And then we, of course, import the libraries. It's again a QTable method. There are a bunch of parameters based off the paper, but you can guess what it is, the volatility, the standard deviation of the value, and the noise trader, um, and the insensitivity demand parameter xi. Um, and then you have to discretize for the value price and uh, well, the noise traders. Is it? Okay. And the Q-learning hyperparameters and all that things you do. So here's the grid, the value grid, and action grid. So here you can discretize the P grid, V grid, and X grid. the order flow, price, and value. And the adaptive market maker, again, the optimization function can be eventually boiled down to this here, which all the gamma and the gamma hat and zeta hats are estimated using OLS regression of the past values and prices. So here's the market maker. It's a class. So it keeps track of a bunch of histories in the past. And then there's an OLS function we need to run and then keep the track of the history. It uses the DQ function. It basically is a queue that gets one new price and kicks out the old price the way past. And then fitting to get the zeta and v. And the price then is basically according to the formula we had it above here, this one here, okay? So this is what we have as market maker. It's called it adaptive market maker because we re-estimate using the past price regressions. So the next step is to, of course, set up the Q trader. It's very similar to Calvano's case. So you have a bunch of parameters set, and then the epsilon greedy learning, and the action is they have the epsilon, and then unpack the state, and then you choose your action of how much order flow you do in terms of the index. And here's the greedy action part. And then your updating is once you get the reward and all this, compute and update the Q table here. All right, so here R plus gamma times the next best Q is the target, and you update it. Okay. So it's fairly similar to the usual Q learning we have done. So here's the random draw because it's always the value, true values are each period are randomly drawn, as well as the noise trader. And information insensitive demand is was it a chi p minus a long run average V bar. And here's the state index. And then here's a single training session. You keep track of the history and market maker, here update the history. But you prime them in a sense that in early on, there are a bunch of zeros. You don't want the program to crash in the early period, so we stuff it with reasonable numbers in the beginning. But once it's up and running, of course, it will be all driven by random noise and all that. So you run a session. So here, the market maker, and then the agent picks its own. And then here's all the priming initial card, and here's the main loop here. So we loop of the agent's actions from the grid, and the noise traders are drawn, and then here's the market flow, and then the price is set, and then the Z is the information insensitive demand, and then you get the rewards for each agents, and then get the next state, and agents update, and market maker also update the history, and you keep doing this for an episode. Okay, so there are a bunch of performance measures, price efficiency, and the price value and profit history, a bunch of things you can plot. So what you can do is run a session on episode, and then we'll just run one episode, but you could do this for different parameters and all, and change and have a grid of a bunch of possibilities of different environment, how the collusion works out. I am just doing it for one particular case. So it may not be too great. And you could learn it for much longer time, so they learn much better. But you can see that it basically makes the profit, and you can see the rolling more in profit. It's not too great, but you can see sometimes it, in the normalized sense, it does better than the Nash equilibrium. And so this, but you have to run it much longer to get more sensible results. Okay, so this was basically showing the Q learning of competing two agents, competing orders, and then try to basically get the most profit out of it. And so it's an algorithmic collusion in a trading sense. All right. So this is all that's about the episode on algorithmic collusion. Thank you.